one's going to be a little bit tricky. All right, we're going to try to divide monomials. So when we're trying to divide, it's actually very, very straightforward. The process that we use is the same as with any other type of division, and essentially what we do is we try to cross out from the top and bottom the same factors. All right, so in this case, what I would actually see, right, is something like this. If we had AB over BC, something like this, okay? That could actually be written as two different fractions. I could write it as A, well, first off, I'd write it as B times A over B times C, right? We see why these are equal because the commutative property actually holds for both the numerator and the denominator. So if I want to flip them, I can flip them. And then if I want to write it, I can actually write it as two separate fractions. So I would write B over B and A over C, right? So these two are equal. And what we should realize is that when you have something that on the top and on the bottom that are identical, it simplifies to 1, right? So that's actually just 1 times that. And 1 times anything, we remember, is actually just, according to the multiplicative identity, just whatever that anything is. So in this case, 1 times A divided by C is just going to be A divided by C. And so we can see how we essentially cross out the b's, right, from the top and the bottom. So in this case, all right, what we have on top is 6, which is 2 times 3 times how many z's? We're going to have 6 z's, right? So I multiply it once, and then let's say I multiply it 5 more times like that, right? And on the bottom I have 3 times z. So it's a little messy here, but I wanted you to see the 3 and the 3 are here, the z and the z are here, and they can both cancel out. So essentially what we're going to be left with is, remember, I could also just multiply 1 by anything, right? So this will equal 3z over 3z times the fraction 2 times z to the 5th divided by just that 1, okay? So think about it. We use commutative property, we moved this in front, and then we separated it, right? So 3z over 3z, and then 2 times z to the 5th over just the 1. We're going to cancel out this part, so it's just going to be 1 times all of that, right? Or 1 times all of it. So when you divide anything by 1, it has the same special property of just actually being the same. So this is going to be 2 times z to the 5th power, right? Now, this is essentially the proper way of really going through all of the identities and properties. In the future, you could just kind of look at it and say, oh yeah, 6 and 3, that's going to cancel. The constants, so there's going to cancel out that 2. Cancel out the 3 and have 2 left over. And then z to the 6th divided by z, that's a property of exponents, where really I'm just going to cancel out one of the z's, so I'm going to be left with the z to the 5th. All right, so I'm going to do the next 10 problems and let you see whether or not you can actually follow along and identify the pattern. So in this case, 4b divided by b. I say I'm going to have 2 left on top. There are more b's on the bottom, so I'm going to cancel out. So I'm going to actually have b squared on the bottom. 9 and 9, those are going to cancel out. There are more r's on the top, so the bottom's just going to be left with a 1, and I'm going to have r to the 8th on top, right? Anything divided by itself is 1. 2v to the 7th times divided by 2 times v on the bottom, right? And remember, there's a very, very big difference between 2, which is times v to the 7th, which is what we actually have, and that actually stands for 2, 1, 2, 3, 4, 5, 6, 7, all right? That's what that stands for, versus if we actually had 2 times v, that quantity raised to the 7th, which would actually mean 2v, 2v, 7 times, okay? So I'm not going to type that out, but in this case, the 2's will cancel out. There are more v's on top, and we're just going to cancel out one of them because that's what the bottom said. We're going to have v to the 6th. Over here, s to the 8th. Over here, notice there are more j's on the bottom, and there are no constants that really cancel out. So we have 10, and then over j to the 6th power. Notice, again, properties of exponents. I have 2 j's on top, 8 j's on the bottom. I'm going to cancel out 2 of them from top and bottom. That leaves me with just 6 in the denominator. All right. Over here, we're dealing with negative exponents. Now, the trick here is a negative exponent is actually just the reciprocal. So all you need to do is flip it, all right? And according to the properties of fractions, if you divide by a fraction, what will happen is that you'll flip it from the denominator into the numerator. And if you have a fraction in the numerator, the denominator just goes straight down to the bottom. So in this case, I'll type it out for you. All we actually have is 1 divided by d to the second power, because that negative 1 will cause this d to go into the denominator. Again, this is going to be the trickiest exercise of the 3 so far, right, of y1, y2, y3. But if you can get familiar with this, it's actually not too difficult, and you begin to start seeing patterns, right? So in this case, I see that the 4's cancel out immediately. I have 3 u's on top, 4 u's on the bottom. I can cancel out 3 of the u's, and I'll be left with 1 on the bottom. All right, so 1 u on the bottom, and I'll have a 1 in the numerator. Over here, again, b to the 0, anything to the 0 is just 1. So in this case, we're going to have 1 divided by b to the 9th. Over here, again, 8 divided by 4 gives us 8 divided by 2 gives us 4 in the numerator. We're going to flip that to the denominator, so we're going to multiply them, and we're going to have a total of 6 of them, right? Since there's 1 already, and 5 more will join. Over here, a little bit more complex, but just like with multiplication, we go alphabetically, right? So 6 is the constant, we do that first, and then a's. Are there more in the top or the bottom? More in the bottom. So I cancel out 2 from top and bottom, I'm going to have a to the 4th. What about b's? There are more in the bottom, so I'm going to have b, oops, let's write that over, b cubed, left over, right? C's, I definitely have more on the top. I'll have c to the 4th. And then d's, I also have more on the top, so I'll have d to the 4th as well. All right, so in this case, when we type it out, what we see is 3 on top. So let me type that. Hold on one sec. 3 on top. More a's on the bottom, so a to the 3rd power. More b's on top. Sorry, more a's on the bottom, so we have a to the 3rd power in the bottom. More b's on top, which is actually b to the 7th power there. C's and d's are equal on top and bottom, so they'll just cancel out. And there we go. In this case, when we look at it, we say more, well, first again, 4 divided by 2. We're going to have 2 left over on top. There are more v's on the bottom, so I'll have 1 v. W's are the same, so they cancel out. There we go. All right. In this case, the y's and the z's will cancel out. 9 divided by 3 is just going to give us a total of 3. We don't need to write 3 divided by 1 because it'll just simplify to 3. All right, so this one is a little bit trickier. It's a little bit messier, but let's see if we can do it, all right? We know there's going to be 7 left. The s's will cancel out. T, this is negative, so I'm going to flip it to the top. So we're going to actually have t squared up top. U's, they're going to switch places, right? So basically, I'm going to have a u to the 5th up top and a u to the 9th on the bottom, right? Something like that. And just like before, we look at it and say, oh yeah, there's more on the bottom. I'm going to cancel out 5 of the u's from top and bottom, so I'll be left with 4. And then v's, there's going to be more on the bottom. So there were 8 v's, 1 more will join it, so we'll have v to the 9th. All right, so take a look at this one and pause if you need to. But you have 7 on top, and then the s's cancel out. The t, which has a negative 2, will flip into the numerator. The u's, basically, because they're both negative exponents, flip places, right? So u to the 9th goes to the bottom, u to the 5th will be on top, and then you just cancel like before, so you'll be left with u to the 4th in the denominator. And then, lastly, we look at the v's. So in the numerator, we see that there's a v to the negative 1st, so that'll flip to the denominator, and then join the other v to the 8th power, okay? Over here, we're really looking at it. Sometimes, again, we could type it out like this if we wanted to, but you should try to plan ahead, right? And what I mean is we'll look at it and we'll say that the 5's will cancel out. These are both negatives, negative exponents, so they're going to flip to the numerator and they're going to stay there. So really the denominator will just be 1. And we'll have f to the 9th power joined by a g to the 8th power. Okay, so if we did this, we'd have to simplify one more time. So f to the 9th and then g to the 8th. But we could have seen that before and planned for it if we had just observed, like roughly where is everyone going to move. Over here, let's see, the q's will cancel out, the r's are going to flip places, there will be an r in the denominator, so why don't we just actually start it off with that. So 9 will be on top, q's cancel out, r to the 5th on top, r to the 9th on the bottom. There are more r's in the bottom, so we're going to actually have r to the 4th, right, because 5 of them will cancel out. There's still going to be an s on the top, and then the t in the bottom will flip to the top, so there we go. 9st over r to the 4th power. If you can do a problem like this, you should be feeling really proud, right? Because it's a tough problem, but I think that, again, it's pretty representative of how you begin to think in terms of finding patterns. Algebra is all about that, and if you can find patterns and you develop a skill set, I think that you can hopefully take it beyond just math, right, and start applying it in daily life. When you see a pattern, you should feel comfortable knowing how you reached it, and you should feel comfortable, again, applying it again and again in situations that are similar. Okay? So let's take a look and see what happens. Perfect. In this case, let's see. We're going to have r to the 8th in the bottom, r to the 1st on top. So 9 will be there, the q's will cancel out, the r's trade places, so I have r and then r to the 8th like this, right? And I'll cancel out one of the r's from the top and bottom. We'll be left with r to the 7th in the bottom and just 9 on the top. All right, challenge zone. Let's take a look, right? And as before with all these types of questions, they just do the same questions, but variations on that theme. And what I mean is they could try to make it longer, right? They can throw in more letters. They can throw in bigger coefficients if they wanted to, and they have bigger exponents. But we shouldn't be scared about this at all, right? So we just go in order. 6 divided by 2 is going to be 3. We're going to have that on top. R to the negative 67 will flip up. So in that case, r to the 4th and then r to the 67th. That will give us r to the 71st. Over here, s to the what power? Be s to the 56. And then over here, this will be t, 6 plus 94, because t to the negative 94 will flip up top. So we're going to have t to the 100th power. And in the bottom, we're just going to have 1. So again, if we planned ahead, we should have just said 3r to the 71, s to the 56, and then t to the 100th power. This would have actually been good enough and saved us a little bit of typing, but that's fine. All right? Over here, let's see. This will flip to the top, this will flip to the top, this will flip to the bottom. So we do need a fraction. So 10 divided by 5 is going to be 2. S to the negative 1 flips to the top. S to the 8 stays there, so we're going to have S to the 9, right? T to the 4th over T to the negative 1st. We look at these two, and really we say, oh yeah, this is going to be T to the 5th power, right? So this is T to the 5th power because we have a negative 1, all right? Anything to a negative power flips to the top. Over here, something on the top is a negative, it's going to flip down, so we're going to have u to the 75th power, and then we're going to be left with v. All right? Over here, let's see. This will come down, so we're going to have a fraction. Yep. So 2 p squared in the bottom. Let's see where the q's go. The q's will go in the bottom as well, so q to the 11th power. Where the r's, r goes to the 79th power. And then s, there's one on top, one on bottom, both the same, so we're just going to cancel those out. And there we are. In this case, we're going to still have the denominator, so 4, 8 divided by 2 is 4, f to the 38th power, right? Remember, if you have a negative exponent on the top, it flips to the bottom. If you have a negative exponent on the bottom, it flips to the top. So the top will be g to the 14th times g to the 6th, which is actually going to give us g to the 20. All right, so in this case, this flips to the top, this flips to the bottom. We'll actually need a fraction. So 3, in this case, it'll be t. We'll have u to the 9th power. V to the 36 goes up top. V to the 1st comes to the bottom. We'll simplify that in our minds real fast. That'll give us v to the 35th. and then w to the 18th times w to the 67. So on top, we're going to have w to the, and what is that? That's going to be 70 plus 15, which is going to be 85. Over here, 5 and 5 will cancel out, m will flip to the top, m to the 6 will flip to the top, m to the 1 will flip to the bottom. So what we're going to have is actually just more m's, so m to the 5th. All right, we don't need the fraction. Over here, q flip to the top, r flip to the top, s flip to the bottom. We'll need a fraction. All right, so let's look in order. So the constants, 5 and 5 cancel out. Q to the 4th is on top, and then we have a q to the negative 1st in the bottom, so that'll flip up, and that'll be q to the 5th power. R over here will also flip to the top, so r to the 1st power, you don't really need to write it. S to the negative 6 means that there's going to be an s to the 6 in the bottom, so this actually becomes s to the 7th power. And then t to the negative 1st will actually flip to the bottom, that becomes just a t. Alright, so in this case, when we look at it, we say, alright, this is going to be a 2 here, s to the 65th power there, t to the 48th power here, and then this is u to the 1st up top, and u to the 9th on the bottom. We're going to actually have u to the 8th in total once we cancel it out. Final question, what we see is, again, we're going to flip 8 to the bottom, 1 to the top, so we're going to need a fraction, right? 2 and 2 cancel out. So if I just had q divided by q to the 8th power like this, what do? I cancel out 1 from the top, 1 from the bottom, and I'll be left with just 1 over q to the 7th. All right.